Hi class! This video is on geometric series. It's section 4.6 in your books. And we in class discussed arithmetic series. And in the last video I discussed arithmetic series. But now we're going to find the sum of geometric series. So just like we had in the last section, there are some formulas that will help us with this. We're not going to derive the formula like we did with the arithmetic series formula. But there are two different versions, and I'm going to show you those on the next slide. So again, as is usually the case, you'll want to take notes on what you see in this video. So you'll notice that we have two formulas for finding the sum of a finite geometric series. Remember, finite means that there's some end, so you'll either be given a last term, the nth term, or you'll be told to find the sum of the first 50 terms, something like that. So in this first formula, if you notice down here, I've noted that you don't have to know the last term. That might come in handy if we're given just the first few terms of a sequence. That means we would know the first term, and we would be able to figure out r, and we would have to be told the number of terms that we want to find the sum for. So remember, n is standing for the number term that you're on. In this case, it would be the total number of terms. Okay, and then again down here, obviously you would need r. So you might want to pause the video so that you can write down both of these formulas. Again, in the first one, we need to find T1, the common ratio, which we need to put in two different spots, and n, which is the number of terms, which is also going here. If I wanted the sum of the first 10 terms, as we talked about, then n would be 10. In this second formula, the second version, in fact, they're the same formula, you don't have to know the number of terms. That also sometimes comes in handy. If I have something like 3 plus 9 plus ... plus 729, I don't know how many terms there are here, but I do know my first term, and I do know my last term, which would be my nth term, or in this case, a sub n. So if you want to use this formula, you still need to know the first term. So any way you slice it, you have to know the first term. Here you need to know the last term. In my little example down here, that was 729. And again, you have to know r, which is your common ratio. So these are the two versions of the formula. You want to choose wisely depending on what you're given in each problem. So on the next slide, we're going to go through two examples. Hopefully we'll use each of these formulas one time. So again, make sure that you've written down these formulas in your notes with whatever notes you need to go along with it. Okay, here are two examples. It's pretty funny that the first one is basically the example that I gave in the last slide, except that my last term was 729, and this last term here is 6,561. But since I know my first term, T1, and my nth term, I don't know what number term that is, but I know it's my last term, so it's the nth term, I'm going to use the second version of our formula. I can also pretty easily figure out what r is. If you notice, we're multiplying by 3 each time here, so r is 3. So if we fill into our formula, there's our general formula, and so we're going to replace the first term with 3. Minus the last term, 6,561, times our r, which also happens to be 3, but that's a coincidence, all over 1 minus 3, which is negative 2. So when you work this out on your calculator, and you should practice this on your calculator, you would get that the sum of this is 9,000, I'm going to put it up here so we don't run into our other problem, 840. So the sum of these terms, if we were to add them all up, would be 9,840. Okay, in our next example, we're supposed to find the sum of the first 12 terms of this series. And so this is a case where I don't know my last term, but I do know n. N is 12. So now I want to use the first version of the formulas, which was on the previous slide. So let's write that down now. And again, we'll start filling things in. So we know our first term. Maybe I should switch colors here. Keep using this red. I don't know what else will show up well here, maybe yellow. Let's see. We know our first term here is 54. So I'm going to fill that in right here. So it's 54 times 1 minus, I forgot to find my ratio. Well, you can always get the ratio by doing a term divided by the term before it. And so I'm going to use these small numbers here. Negative 2 divided by 6 is negative 1/3. So my ratio is negative 1/3. So I want to put that in parentheses since it's a negative. And that gets raised to the n, which in this case is 12. All divided by 1 minus, be careful with this, negative 1/3. So down here in the denominator, I think we know that becomes a positive. Okay, and I'm missing one little extra set of parentheses up here. So in the numerator, you'll want to work out what negative 1/3 to the 12th is. Now that's going to be a decimal. Okay, and that makes sense for this series because you'll notice if you look back up at the terms here, the numbers are getting smaller. The next term here, in fact, is going to be a fraction. So we're now going to be into fractional numbers, which means our answer could be a decimal, which we would then convert to a fraction. And when you do this out on your calculator, you get 40.5 with a bunch of zeros and then a little extra. So we could say that this is about 40.5. So that's two examples, one using each of the formulas that you learned on the previous slide. Pause the video now if you need to go back and see what it was that I did, or rewind and listen to it again. We have one more slide to cover. I wanted to just give us a little extra practice with sigma notation because I know we had a little trouble with that on the previous night's homework. So in both of these examples, it says evaluate. Whenever you're told to evaluate something, that means to find the actual number, okay? So we're actually going to want to find the sum of the first 10 terms of the sequence that we get when we use this formula. So first we can start doing out a few of the terms if you need to. To find my first term, that means n would be 1. I would put 1 into this, and so that would give me 2 times 3 to the 1 minus 1, which is 2 times 3 to the 0, and anything to the 0 power, except 0, is 1. So this first term is actually 2. My second term would be when n is 2, and so I would put 2 into the formula for n. Whoops, that's 2 minus 1. And so I get 2 times 3 to the first, which is 6. And my third term would be if I put in 3 for n, and so that's 2 times 3 to the 3 minus 1, which is 2 times 3 squared, which is 9 times 2, 18. Hopefully now you can see my first three terms are 2, 6, 18, that this is geometric, and each time I'm multiplying by 3. So I now know this is geometric, and that my r is 3. I just found my first term here, and I know the number of terms, and so we could now go to our sum formula, the first formula that I gave you. If you wanted to, you could also find the 10th term, the last term, by putting 10 in for n, and then you could use the second version of the formula. So at this point, I'd like you to finish this example by using one of the formulas that you learned on the first slide, given that your series is 2 plus 6 plus 18 plus 7 more terms. So pause the video so you can work that out. And on to our final example, example 4. Here, be very careful. The terms go from when n is 0. So when I put in 0, that's actually going to be my first term, up to when n is 12. Again, be careful with this because a lot of people make the mistake of thinking there are 12 terms here, but in fact there are 13 terms. So you might want to put a little star next to that there are in fact 13 terms to this, not 12. So to find my first term here, I would put in 0 for n, be careful. And so if I do that, n equals 0, I end up with 100 times 1/2 to the 0. Again, 1/2 to the 0 is 1, so my first term is 100. To get my second term, be very careful with this, I have to put in 1 for n. That's a little different. We've been putting in 2 when we want our second term. And so I would do 100 times 1/2 to the first, which is 100 times 1/2, which is 50. Okay, my next term would give me 25, and so on and so forth. Hopefully, maybe after these two examples, you're noting that this is looking like a geometric sequence formula. It's my t1 times r to the n. It's missing the n minus 1, but that's okay. And over here in the first example, there's my t1 times r to the n minus 1. So if you can recognize right away that it's geometric, you could just go right to the formula. If you don't recognize that, you could list out some of the terms as I've done in both examples down here. So now we know this is geometric, and my r is 1/2. So again, you could use one of your formulas from the first slide to find this sum. So you can finish that up, and tomorrow we'll go over these two answers in class. That's the end of this video. You have a few more problems to do in the book, and that's it. Have a good night. Bye.